So as I was trying to say, I'm going to grade the whole thing this time so that people get credit for the effort they put in. But after this one, we're going to go back to the old system. The rest of the homework will not be algebraically intense the way this one was. This is probably the hardest one you'll have all year. If you're paying attention, the rest will be more conceptual. The algebra in this thing was way more tedious than I expected, and this just turned out to be a very hard homework. But some people came to my office yesterday and really struggled and tried to find me today and managed to get it done. And some people get it and understand how to do this stuff, and I want to give those people credit. It was a good test of your knowledge of this material to date. If you couldn't get through any of the parts of any of the problems, then you know, you've really got some work to do. And it's also a good lesson about keeping up. If you're not keeping up with this course as we go along, you're going to get completely lost and you're going to have no clue after a while. So if you don't understand concepts, you can't wait until 12 o'clock or 3. We're trying to find me at 3 o'clock today to try to ask questions to get it straightened out. You need to start your homeworks early enough so that I have a chance to give you the help you need. And I just can't do that 3 hours before the test when I have to teach a class this afternoon for 2 hours right before this one. So it was impossible for me to give some of the people all the help they needed because I just didn't get to you soon enough. And so I'm going to do my best. You know, I was there for 3.5 hours yesterday, and my office was pretty full the whole time. And then I did another hour this morning, not quite a half an hour or something. Tomorrow I have a department meeting at 3:30, so I'll be there from 1 to 3:30. Is the best I can do. And so I'll have another, you know, way overboard office hours to try to make sure that you have the help that you need. So, so that's that. So I'm worried that this homework has instilled a level of fear and sort of it's going to point you in the wrong direction about what you need in the test. So I want to spend some time today sort of giving you a better idea of what I'm going to expect on the test, because I think you need it. I think you're very clear on that right now. You simply don't have the time, and I don't want to allow the use of calculators on the test to do some of the kinds of algebraic problems that are required in the homework. That's why they're in the homework. So on the test itself, there may be some simple sorts of things that you can do in a couple of minutes if you get it, but the sorts of find the I and Y for a full ISLM model is probably not something I can do on an exam, but I can certainly ask you conceptually about things. So I don't expect there's going to be a lot of algebra or pure math. I could ask you to use multiplier formulas, calculate changes in equilibrium, and that sort of thing. You don't know what I'm talking about. I ask you questions later today, and I'll give you some examples. But in terms of, you know, what was in the homework for today, that's a little bit more than I can probably expect on the exam. So let me go through and sort of outline what I think of as the main topics and what I'm going to emphasize on the exam. And that'll give you some sense of the things you can focus on, and then I can go back through and give some examples of what I mean in each particular part. So the main topics that I think you covered were first, how to measure GDP. So there was some intro material, but the meat of what we got to is how to measure GDP. And then we talked about three different methods for doing that. Income, so you can add up all the income in the economy. You can take the value, the total value of final goods and services. Or you can take value added. And then we did a bunch of examples to show that all these three things give you the same exact answer in terms of calculating GDP. So I wouldn't hesitate to give you a very simple example. Here's 2 or 3 goods, here's their prices. Calculate nominal GDP, explain without reducing fractions or anything how to find real GDP and those sorts of questions. just exactly what we did in class, those sorts of things. We put out a simple table. I think there were 3 products in it or something like that. Those sorts of things I think are fully fair game in terms of what we can do. We talked about nominal versus real GDP, how to calculate each. That was in your first homework. Simple examples along those lines would be fine. We talked about the unemployment rate and how it was defined in particular. So I could certainly ask you, how is the unemployment rate calculated? Why is it important? Why do we care about it? What's the labor force? And all those sorts of questions. And so, no problem there. All those things will be on the test. The price level and inflation. So again, this was all homework 1 sorts of things with those examples that we did. So how to calculate a price level. We did 2 types. We did the implicit GDP deflator, which was simply nominal over real. And then we also talked about price indexes, like the CPI, the personal consumption index, the PCE. So there's this thing called the implicit GDP deflator, and these are things like the CPI that you hear about in the news, or the personal consumption expenditures index, it's called the PCE. These are indexes of households' cost of living. So these are cost of living indexes for a household. This is the cost of a unit of GDP, which includes government goods, investment goods, and consumption goods. This is mostly just consumption goods, the typical household would do. We did examples of this one in the homework. We didn't do any examples of this type, though we hinted at how chain type indexes are calculated in one of the problems. The very last problem, chapter 1, was all about how these chain type indexes are calculated. And so there's that. But probably for numerical, that's probably what I would focus on, since you didn't do any examples of these. These, though, conceptually, I would have trouble asking about that. And how to calculate inflation is just a percentage change. Then we talked about Okun's law. And we talked about the Phillips curve. What they are, what they tell us, how we might use them. So for that section, the what they are, we drew a graph of each one, and then talked about how to interpret points on those graphs. And so that would certainly be fair game. And that ended the introduction. Yes?
Chapters 1 through 6, is that correct?
Yeah. Focusing on the topics that I'm highlighting. So I don't know that there's much in chapter 1 other than, I can't remember where the GDP calculation comes. I think that's like chapter 2. So,
Yeah. But it goes
Just
just
above.
up to chapter 6.
if I covered it in class, it's fair game. If it's something in the book that I didn't talk about, it probably means I didn't think it was important enough to talk about. It seems kind of silly to me to test you over things I didn't think were very important.
I think it's chapter 5, actually.
I'll look here. I should have done that before I came in the door. Yeah, we didn't do chapter 6. Chapter 5. Thank you. Wherever these topics are, let's get through chapter 1. Then we did the goods market. Talked about C, I, G, consumption, investment, government spending. C equals C of Y minus T. I equals I of I and Y. Or earlier, I equals I bar We started with I fixed, then we did a more general case as we went forward. G equals G bar. We didn't put a bar over it, but G was just some fixed number. Taxes was just some fixed number. And then for sometimes we did specific examples. So this was a general function. Sometimes we used C equals C0 plus C1 as y minus t to sort of show you how it works. And sometimes we did I equals B0 plus B1y minus B2i in your homework anyway, as an example of that function. But those were just examples of these more general functions. So we said, okay, consumption depends positively on disposable income. Here's an example of a consumption function where this is the MPC. So you want to know all about this consumption function and what it means. We talked about what C0 means. This is autonomous consumption and all the things it picks up and represents. So we went through the interpretation of C0. C1 is the MPC. You'll have to know about that. So we talked about that. We said investment, so it depends positively on this. Investment depends negatively on the interest rate, as you can see from the example, and positively on income, as you can see from the example. So this was a general case. This was a specific example of an investment function. And so, when we talk about why investment, why it might depend negatively on the interest rate, why it might depend positively on income, so I can ask you that. Why is investment negatively related to the interest rate? Why is investment depend positively on income? It's in the book too. We went through that stuff. That's all would be fair game to ask those kinds of questions. The test itself will attempt to test various levels, so I expect there to be easy questions, maybe even some definitions that are very simple. See if you know what is the MPC, what's autonomous investment, those sorts of kinds of things. Define what those are. I'll have some easy questions to see if you get anything. And then there'll be some questions that try to differentiate A's and B's as well. And so there'll be a variety of levels. We'll see how far you can go. So all of that sort of material that we covered will be there. We talked about the equilibrium. That y equals c plus I plus g. We did this equilibrium graphically with a 45-degree line diagram. So you should know how to do that part. Explain why it's an equilibrium. We talked about if you're not at equilibrium, why you might move back there because inventories are piling up or inventories are falling. If income and expenditure are equal, then inventories will change. So we talked about all of those sorts of questions. So you should be able to explain how this model works, how income would change and why it would change if government spending changed or taxes changed or one of the other autonomous variables changes. This thing will shift up and down. We went all through those problems. So, what would happen if autonomous consumption went up? What would happen if taxes went up? Government spending? Those sorts of things. What would happen to this curve? For those who are coming in late, remember that once we draw the numbers, we're not going to take the homeworks. And so you may get lucky this time, but from now on, right now, I wouldn't take a homework right now, just so people know. So all of that is fair game. Talked about the multiplier and how to use it, why we care about it, how to use it, those sorts of things. And you can ask me questions on any of this later today. So we talked about simple multipliers, and your homework started to talk about more and more complex multipliers as well. And so all of that is sort of fair game, and what else I'll talk about in a few minutes. So the simple multiplier for sure, the 1 over 1 minus the MPC. Later that 1 over 1 minus C1. Later that was 1 over 1 minus C1 minus B1. That kind of stuff. But those sorts of multiplier problems are hard. You ought to know about the multiplier, what it is, why it's useful. Then we talked about an alternative approach to equilibrium, where we did roughly saving equals investment. And this was the S plus T equals I plus G. I think we wrote S equals I plus G minus T. How to get from Y equals C plus I plus G, this equilibrium, to that one is fair. Remember how to do that? This was C plus S plus T. That's all the uses of your income. You either consume it, save it, or it goes to taxes. Just cancel the C's and you're there. But so there's two ways of looking at the equilibrium: the savings equals investment approach, and the income equals expenditures approach. And so you get it from one to the other and sort of explaining this is leakages equals injections, and this is income equals expenditures. Then we did sort of a circular flow thing to try to explain it as well, but I'm just mostly interested in sort of understand intuitively why these are equilibria. At least be able to get from there to there. We drew some graphs of this, but I don't think those graphs are in the book, and I didn't really have to work with them much, so I'm not really worried too much about the graphical part here. But I do want you to be able to get from there. Then, we were done with the goods market. So the equilibrium, the shifts, all of that sort of thing for the goods market, why the equilibrium changes. Then we did money demand equals money supply. We did the financial market. So we moved in from the goods market to the financial market. Money supply was easy. We said money supply was exogenous. And money demand was PYL of I. So this just assumes the Fed controls the money supply perfectly. It's not quite true, but that's an assumption in our model. It's okay. This says money demand depends upon prices, income, and interest rate. This is negative. And then we explain why it's positively related to income or prices. If you buy more stuff or it costs more, you need more money. And negatively related to interest rate, that's the opportunity cost argument. The opportunity cost of money goes up, then you're going to hold less of it. And then we did the graphical representation of the equilibrium, Py of I over M and I, and talked about how the interest rate is determined. And then we talked about how and why this curve shifts, if P shifts or Y shifts. And then that's going to change the interest rate, and then you should explain why, intuitively, why the interest rate goes up or down, the money demand goes up or down. Then we went on to bond prices and the interest rate. That is why they're inversely related. It's because the price was equal to the return over 1 plus I. We use this formula. So P is, an example was P was 100 over 1 plus I. That thing, so P and I have to be inversely related. You need to be able to explain an example like that. And explain why prices and interest rates are inversely related. So the kind of simple example we use in class. That'll help you understand why, for instance, when the money demand shifts up, why the interest rate would go up. You can talk about, well, change in the demand for bonds, and the price of bonds changes, so the interest rate has to change. So at that point, you should have known all about two different models. So we had a goods market model, which was the 45-degree line diagram. Then we had a financial market which was the money demand equals money supply. Sometimes we wrote this as M over P and left this P out. So we use two different versions of this model sometimes, but it's the same model. So this was the goods market and this was the money market. Then we needed to pull them all together to find the equilibrium, the simultaneous equilibrium of both markets. So we first used this thing to get the IS curve. Then we use this thing to get the LM curve. And then we just put them together into the IS-LM diagram. So we did the IS first, which I'll talk about when we do the IS curve, then we did the LM curve, we'll talk about that. Then we did IS-LM. So for the IS curve, we derived it from the 45-degree line diagram. So we put another graph down here. We worked out the relationship between I and Y. Then we did how it shifts. And then we did why it was flatter or steeper. And we did two cases, the MPC, which I call C of Y minus T in the notes sometimes, and the responsiveness of investment to the interest rate, which I call I of I in the notes. So we talked about how the slope, and not mathematically, but we did these graphically. So in one case, you get two different shifts, in another case, you get two different slopes of the expenditure function. So that's all we did with the IS curve. Write it, show how it shifts with, say, a change in government spending or taxes or other autonomous variables, and how it changes slopes if one of these two things change. Either one of those go up, it gets flat. That's what we showed. Then we did the LM curve. So we derived it from the money demand equals money supply diagram. We showed how it shifts. And then what makes it flatter or steeper? And the only parameter we looked at here was the responsiveness of money demand to the interest rate, what I call L of I in your notes. That gave you two different slopes of the money demand curve that we just derived the LM curve twice, and we have it. So up until there, it's pretty much all graphical and intuitive is what I would emphasize in all of that material. So show me how the IS curve, use the 45-degree line diagram to show how the IS curve shifts if taxes go up. Drive the LM curve, show the LM curve is flatter or steeper if. Those sorts of questions I think are just fine. Yes, sir. There'll be several questions. I can just go ABC, so it's sort of. Yeah, there could be a couple of short answers, some definitions. So we'll see how it goes. I need to make it doable in an hour and 20 minutes. 5 questions, maybe 4 questions, and some definitions, that kind of thing. Some might have several parts. So I can step you through it and try to give you some points or something.
So how do you put right
Hmm?
to, what format, how do you write
Well, the best and the most complete answers will get the most points. And so if you know something and don't tell it to us, we can't give you credit for it. And so if you explain the answer well in an understandable way, you'll get credit for it. If I can't figure out what the heck you're talking about, you probably won't. And so you want to make it complete enough so it's very, very, very clear and that you really understand the answer. And so if you have a choice between a short couple of little arrows and things, which we won't know what that means, and giving us a nice full answer, that's your choice, but you're taking a risk the shorter you make.
Do you get partial credit?
Yes.
For,
Correct things.
yeah.
Zeros are possible. In some cases, so IS curve, drive it, what makes it shift, what makes it slope, LM curve, same three things. Then we put the IS and LM together. So then we did the IS and LM together. Can't be the first time I've raced today. What I just- So, the equilibrium, IS, LM, there it is. And then we did what changes the equilibrium. So we did fiscal policy, which was G, and T, and monetary policy, which was M. And we did these graphically and intuitively. And we also did with fiscal policy crowding out, explain how that works. And that was part of the intuition as well. We did that both graphically and intuitively. And that was it. Right? That was the end of it. I didn't talk about crowding in class. There is a crowding in. I didn't focus on it in class.
Essentially opposite, not necessarily.
Crowding in refers to the change in investment when the income changes. And I didn't talk about that, so no. And I could certainly give you a simple example like, C equals C0 plus C1, 1 minus T, I equals I bar, G equals G0, find equilibrium, Y, multiplier, and all those sorts of things. Find the equation. I could give you a different investment function like I equals B0 plus B1 Y minus B2 I, and say find the IS curve. But beyond that, it's going to be tough to do much with the equations. So using simple models to find the equilibrium, maybe finding the IS and the LM curve. The LM curve is trivial. You just money demand equals money supply and solve for Y. But beyond that, I can't do much algebraically on the test. And so I wouldn't expect, although I could ask you simple algebraic kinds of questions to see if you get the material as one of the harder questions, to test people's knowledge. It's just not going to be a very involved, it's not going to be the focus of the test anyway. I'm more interested in you understand conceptually how to manipulate the graphs, what they mean, the underlying intuition. The math is just another way of expressing those same ideas So if I can get the ideas to you in your head, 2 of the 3 ways, every problem you can do kind of graphically, mathematically, intuitively, so there's 3 ways to do them. If I can get you at least doing 2 of them and maybe some of the third on the mathematical side, then I'm going to be happy. And so that's going to be where the focus is, which is not to say there won't be any algebra whatsoever on the test. It's just not going to be really long, hard problems. And I can't ask you anything else. And I'm sorry if I'm being serious today, but I just want to send some message to some people in this class that they're just not putting in the effort that they need to put in to get by. And we're in here to learn, not to screw around, not to talk, and those sorts of things. And so, I just think it's time to send a message to not everyone in the class, but to some people. You're not showing up, you're not doing the work, and it's not going to go well for you. If you're not getting it to this point, at least graphically, intuitively, you got no chance as we go on. And so this is a good time in the next couple of days, and the next week or 2, sort of take a step back and fill in the holes that you missed. And so, so now, how can I help you? What kinds of questions do you want me to answer?
You go into more depth on responsiveness and labor side or just looking at curve.
Yes.
How do
So the question is, can you show us how the slope of the LM curve depends upon L of I, the responsiveness of money demand to the interest rate? So the way I did this problem was to first say the slope of the money demand curve depends upon L of I, the responsiveness of money demand to I. Now let's not worry exactly what the relationship is. Let's find the answer and then back up. So what we're saying is, first of all, I'm not doing this problem yet. I'm just going to back up and remind you how to derive the LM curve. What we need to do is derive the LM curve twice. We're kind of going to do it simultaneously in one diagram. We want to derive it once with a small L of I, once with a big L of I. So what we'll get is 2 different slopes. And then we want to see how that changes the LM curve. But let's just remember briefly how you derive the LM curve. So here's P0, Y0, L of I. And here's M0. So I give the model a price, an income, and a money, and it spits out an interest rate. That's the endogenous variable. So it says, okay, Y is Y0, and I is I0. So we can go over here and find that point, Y and I. So we say, okay, there's I0, and there's Y0. Now let's raise income to Y1 and see what happens to the interest rate. That'll give us the relationship between Y and I in the money market. So if we increase income, this thing shifts out to P0, Y1, L of I, and the interest rate goes up to I1. So at Y1, the interest rate is I1. Now we have 2 points on the LM curve, but that's enough for us to see what it looks like. We could pick a bunch more incomes and sort of map out the whole thing, but that's enough. So now we know the LM curve looks like that. So that's what I mean by derive the LM curve from the money demand, money supply diagram. So that was one of the 3 things you needed to do with the LM curve. Now what we want to do is say, suppose this money demand curve were flatter. How would our answer change? So let's do that next. Now let's actually answer the question. So, now let's imagine that we have two different money demand curves, P0, Y0, L of I. That's one of them. And another one that's flattened, P0, Y0, L of I. And the only reason these two curves differ is because of a different value of L of I. Yes.
Over here, the income
Huh?
grew,
Yep.
and the P, YL, it shifted to the right.
Because this is big.
Because Y increased.
Right, right. That's exactly right. And so we started off with money demand equals money supply. Then income goes up. That causes money demand to go up. That causes money demand to be greater than money supply.
The M here on the left, it stays the same.
It stays the same. We only want to know how Y and I are related, all else equal. So when money demand is greater than money supply, people want more money. So they sell bonds to get more M. There's a shortage. So they want to get more money than there's out there, so they start selling bonds to try to get money in their pocket. That causes the price of bonds to go down, and we know that from that inverse relationship that the interest rate has to go up. And so intuitively, that's why income and the interest rate are positively related. Does that help? Yeah. I forgot, I should have done that. So that's what I mean by explain intuitively. Just drawing these arrows is part of it. You want to use words, make sure we know that you understand. You just memorize arrows. I guess you can memorize the explanation, but then I just don't want to know the words that are somewhere. Okay, now we're going to start off at Y0 and I0. So we're going to start off here at I0 and Y0. And then we're going to do the same thing. We're going to let income go up to Y1. And that's going to shift both of these curves out. So we just take that point at intersection, lift it up, carry those two lines over, and set them down right there. It shifts both of these lines horizontally by the same amount. With me? And so for the flat curve, it'll shift parallel. So that's that curve, shifts to there. And the steeper curve, I shouldn't have gone quite so steep, will intersect up here somewhere. Okay? So I either get to this interest rate, that's the I with the flat money demand curve, and way up here somewhere is the I for the steep, right there. With me? We have two different money demand curves. Steep one, they both shift out. The steep one shifts by the same amount. This one shifts. They shift by the same amount. The steep one, you hit the money supply curve up here. The flat one, you hit the money supply curve there. So the interest rate goes up either to I flat, or let me just put it right here, I steep. Just pretend like it hits right here. So at Y1, you either get this interest rate or you get this interest rate. Same increase in Y, but you get two different increases in the interest rate. So you either get this LM curve for the flat money demand curve, that's this intersection, and then from there to there, when income went up. Or you get this one, you get a very steep LM curve with a steep money demand. So the steepness, so the difference, L of I, is the only thing that's different between the two. So these have two different responses. Now what I'm going to do is explain which one of these money demands has a bigger L of I. I wanted to do this just mechanically. This is how you're going to do the problem. L of I means the slope differs. So you take two different slope curves and simultaneously derive two different LM curves. But the only reason those things are different is because of the different LI. And you can memorize the part I'm about to show you just to start out. Now, when is money demand flat? What value? For L of I, we're only talking about L of I here. So is it when it's big or when it's small that the money demand is flatter? So we take the money demand curve, it looks like this. P, Y, L of I. We want to know about the rise on the run, right? So what I want to know is how money demand changes when the interest rate changes. So if I lower the interest rate and money demand goes up that much, so if I lower the interest rate from I0 to I1, and then money demand goes up from NB0 to NB1, then I'm going to get this slope, right? So I just lower the interest rate, money demand goes up. And the more that money demand goes up, what happens? It's going to get flatter. So we're saying when the interest rate goes down, money demand goes up. And the amount it goes up depends upon L of I. That's this is the responsiveness of money demand to the interest rate, right? So if it's more responsive, you get a bigger change in money demand. That's what it says. It's the responsiveness of money demand to the interest rate. So when L of I goes up, that means more responsiveness. So for the same fall of interest rate, I get an even bigger change in money demand, right? If it was more responsive. So the I goes down from 7% to 6%. So there's a 1% change. Fix that. In one case, money demand goes up by 4. If it's more responsive, money demand goes up by 8. Okay. So if we're working that out, we say, okay, here's 7 and here's 6. So we're going to start off at some point. Y0 and M0, MD0, whatever that is. Then we let the interest rate go down to 6. In one case, it goes up by 4. So in one case, the change would be 4. When the interest rate goes down, money demand goes up by 4. So that would give us one money demand curve, right? But if it's more responsive, this is the more responsive case, it's going to go up by 8. And so you'd be there. For the same fall in interest rate, you get a bigger change in money demand. Instead of getting to that point, you get there, so the money demand curve would be flatter. So the more responsive it is, the flatter the money demand curve becomes, and the flatter the LM curve becomes. So this is the more responsive case. And this is the less responsive. Because those correspond to the steeper and the flatter money demand curve. Steeper money demand is less responsive. Only goes up by 4. We drop the interest rate by 1, it went up by 4. So we get this money demand curve. If it goes up by 8, we get a flatter money demand curve. See that? And so you say, to do this problem, you say, okay, when it's more responsive, the money demand curve is flatter. So you write down two different ones, more responsive, less responsive, and then derive the LM curve twice.
For responsiveness, to essentially almost unless.
I'll say, show that as money demand becomes more responsive to the interest rate. Show how the LM curve slope changes as money demand becomes more responsive to the interest rate. You say, oh, that means it's flatter, and then derive it twice.
So it's essentially just changing the interest rate or changing the
Exactly.
Just to help explain some of the stuff on the essay questions, because we kind of drew like a small graph.
Oh, you should draw graphs. And then just explain them.
Okay.
Yeah. Please draw graphs. That's why we're doing everything graphically. So for this one, it's almost purely graphically. The intuition, the slope of the LM is when I goes down, money demand goes up. Well, no, let's not do it that way. I'm not going to ask you that. There's a thing here I don't want to do. You have to use one, just never mind. So this one I'm not going to ask intuitively, just be able to and explain. So the question would be, as money demand becomes more responsive to the interest rate, how does that change the slope of the LM? Something like that. If you know this part great, just start here and say, okay, when LMI is bigger, money demand is flatter. Write them down, do the graphs. Anybody else wanted to use this? Show how the LM curve shifts if price goes up graphically. So this is the shifts in the LM curve. So we've derived the LM curve. We've done the slope. That's the only case we did for the LM curve right there. We just had one slope case for the LM curve. That was it. So the other part of the LM curve was shifts in the LM curve. So show graphically how the LM curve shifts if the price goes up. How do I do that? What do I start with? So pretend like we've already derived the LM curve. It actually depends upon M0 over P0, its position. So we start at this I0 right here, and that's going to give us this Y0. So we're going to start at that point on the LM curve. So we're not deriving, we've already done that. Now we want to show it shifts. So the question is, when the price level goes up, does the LM curve shift out or in? Explain to me graphically why. Show graphically which way to shift those. So what you want to do in this problem is hold income constant. And just see, when price goes up with income constant, does the interest rate go up or down? So we're going to let the price go up to P1. That's going to shift this out. P1. We're going to keep income at Y0 and see what our new interest rate is. So we're still at Y0 here. Notice that the interest rate is suddenly higher than I1. Any equilibrium has to be on the LM curve by definition. It's the set of all equilibrium points. And so the new equilibrium has to be at Y0 and I1. So the LM curve must pass through that point. If it's an intersection over here, it has to be on the LM curve by definition, because it's all equilibrium points again. And so it must be that the LM curve shifted up. These are the kinds of things I'm most interested in knowing that you can do. Not all that complex, tedious algebra that was in the homework. I'm more interested in the graphical conception. So price goes up, money demand goes up. We've held income constant because money demand goes up, that drives the interest rate up. We talked about why a minute ago. So at the same income, the interest rate's higher, so the LM curve must have shifted back. Okay. How would you do, show me how it shifts for a change in M? What would you do?
All geo depends on constant.
Exactly. So you would start with the money demand, money supply diagram, and an LM curve, find that initial equilibrium, hold income constant, and then see how the equilibrium changes when M changes. So in this case, you would start with what? M0, P0, Y0, L of I, I0. That Y0, I0 has to be on the LM curve. So we're at this I0 and Y0 point. With me? The money supply goes up. So what happens on the left-hand diagram? The vertical line shifts to the right. So the interest rate falls, but we have not changed income. So that's not the best horizontal line ever constructed on a chalkboard. But chalkboard's wavy, you just can't see it. So there's I1. So that has to be on the LM curve. So the LM curve must have shifted out or down, depending on which direction you want to describe it. Sure hope that camera's running. Looks like the shutter's closed. Maybe not. So that's all there is to shifts in the LM curve. So we've covered everything you can do with the LM curve. Intuitively, what's going on here? Money supply goes up. You start at equilibrium, money supply goes up, so money supply is greater than money demand. People have too much money. What do they do with the extra money? They buy bonds. So the price of bonds goes up and the interest rate goes down. Another way to think of it is interest rate's the price of money. When the supply of money goes up, the price of money falls. The first intuition is probably a little more complete, like both of those are sort of explained. So at the same income, interest rate's lower, so the L curve must have shifted. Then you do the same exercises for the IS curve. Divide it, show how it shifts, and show how the slope changes for those two cases instead of one and for the IS curve. But you do it with the 45-degree line and the IS curve back vertically. But you do the same sort of manipulations.
Can you do one of those real quick?
I was trying to lead someone to ask that. Happy to. We covered most of the class. You want to take a break first?
Yes.
Right. Or do you want to use all the time we have to review? How many want to break?
Right.
How many don't? Pretty much the tie, so we're going to have to go with the standard. So let's break for 5 minutes and 5 minutes only. So I'll do the same things for the IS curve that we just did for the LM curve really quickly. Then I'll show you the ISLM things that I want you to do. And then I'll give you an algebra example just for fun. Then we will have pretty much covered all the hardest bases in the course. We calculate the price indexes and GDP and stuff like that. The things you really ought to be able to get on your own with some effort. But this is probably the things I should focus on for a little while. So let's derive the IS curve, show how it shifts, and then show what changes its slope. Same three things we just did. Now in this case, it's a vertical alignment because they share the vertical axis. So we're going to take the 45-degree line diagram. We're going to remember that investment is some function of the interest rate and income. So we're using an example of this as I equals B0 plus B1Y minus B2I. So it depends negatively on that and positively on that. You should be able to explain why, but that's something you can read about or whatever. So we have this equilibrium. It's C plus I. C depends upon Y minus T. Let me just put it all out there. Plus I of I0 and Y plus G. So that's the expenditures. That's Z, what we've been calling expenditures, demand. We've given that several names. So when the interest rate is I0 and T is T0 and G, these also have some value. They're exogenous variables. But when I is I0, all else equal, income is Y0. So we can come down here. This is, we want the IS curve, how I and Y are related. So we can say, all right, when I was I0, Y was Y0. Then we can ask, how does Y change when I changes? So we say, okay, let's suppose that the interest rate fell to I1. Suppose the interest rate falls to I1. Then investment's going to go up because it's a negative relationship. So it's going to shift this curve up. How far it shifts depends upon how responsive investment is. But that's about the slope. We'll come to that in a second. But for investment has some responsiveness to the interest rate. It shifts up. So it shifts up when the interest rate falls. C of Y minus T plus I of I1 and Y plus G. So when the interest rate is I1, output goes up to Y1. So it must be that the IS curve is negatively sloped. Intuitively, all that's going on is that when the interest rate falls, we let the interest rate fall, we want to see what happens to income. So when the interest rate falls, investment goes up, shifting this curve up. that causes expenditures to be greater than income. Initially, income equal expenditures, interest rate falls, that makes spending go up. So now spending is greater than production. Let me say production here, because that might be a little more intuitive. Production or income, you can say it either way, because those are equal. That's what the different ways of calculating GDP is all about, to show those are equal. So that means that inventories fall, and when firms see their inventories falling, they tend to increase output. So we see a negative relationship between the interest rate and income. So that's the intuitive story. Interest rate falls, it drives spending up, people start spending more, production hasn't ramped up yet, inventories begin falling, that's a signal to firms to ramp up production, and they do. So the interest rate falls, that drives spending up, spending goes up, inventories start falling, and then firms ramp up production and match the higher level of spending. That's the story. That's why it's negatively sloping. And then how flat it is just depends on how strong each one of these arrows are. How much, that's the responsiveness of investment to the income, right? That's to interest rate. So how much investment, if it was more responsive, this goes up more, right? If investment's more responsive to the interest rate, investment would go up more for a given fall in I, right? That would give you a bigger change in Y. If you had a bigger change in Y for the same fall in the interest rate, what's going to happen to the IS curve? It's going to get flatter. We'll show that graphically in a second. So when you get a more responsive, you can do it intuitively too. When you get a more responsive investment response, you get a bigger change in income and a flatter IS curve. So that's the intuition for the slope. Right here, when investment goes up and income goes up, this link here between is the multiplier. 1 over the simplest case, that's the word simplest I've ever written, but that's what that's supposed to say. The simplest case is 1 over 1 minus the MPC. So when the MPC goes up, the multiplier gets bigger. So for a given change in investment, you get a bigger change in income and the curve gets flatter. Because the multiplier is bigger. So when the MPC goes up, you get less leakages for circular flow, if you remember your 202. And so you get a bigger multiplier and a bigger change in income for a given fall of the interest rate. So again, that's going to make it flatter. So when the MPC goes up, the IS is flatter, and when the responsiveness of investment goes up, the IS curve is flatter. You can see that. The second one, it's easier to see the second one if you just shorten this up and say, okay, here's where the two parameters. When investment goes up, income goes up, and this is the multiplier. And when the MPC goes up, the multiplier goes up. So you get a bigger change for a given fall in the interest rate and a given responsiveness. A bigger multiplier gives you a bigger change in Y, so you get a flatter curve, just like the other case. We'll show that graphically too. That's the intuition for the slope of the IS curve. It's just we drop the interest rate by a certain amount, and the more income goes up, the flatter it gets. When will income go up more? Well, when you get a bigger change in investment, or when you have a bigger multiplier. So in either case, you're going to get a bigger change. So now, but I'm getting a, should I do the slope now and then do shifts? Since I'm already doing the slope, I might as well just continue this. Then we'll do the shifts in the IS curve last. So let's do the responsiveness first. So just like the LM curve, what we want to do is derive the LM curve twice, or the IS curve twice. One for a small responsiveness of investment, and one for a big responsiveness. Okay? So we're going to start with the same setup. 45-degree line diagram, C of y minus t plus I of I0, and y plus g, y, I, y0, I0, and I0. Now, what the responsiveness tells us about is how far that curve shifts out. And so it tells us when we drop the interest rate, investment goes up by a little bit or investment goes up by a lot. So we drop the interest rate, the investment goes up. How much investment goes up tells us how big this shifts. So if we get if we had a really small responsiveness, so we're going to let the interest rate fall to I1. We want to see how much income goes up. With a small responsiveness, a small change in investment, you get a small shift. So C of y minus t plus I of I1 and y plus g. So this is the case for, it's a small shift since small responsiveness. I of I is small. So in that case, income would only go up by a little bit. And so you get a very steep IS curve. And so it's not very responsive. You don't get a big income boost here. You don't get a big shift because there's not much of a change in investment. So you get a very steep curve. Got that? Now if we had more responsiveness, what happens? You get a bigger shift. So if it's more responsive, you might go to C of y minus t. It's the same fall in the interest rate, it's still I1. We just get a bigger change in investment. So this is the case for a larger responsiveness. It's a bigger shift, right? So it's a bigger shift. We get a bigger change in output because we get a bigger change in I. Same multiplier, we get a bigger change in Y. The MPCs are the same. The only thing that's different is the responsiveness. So in that case, for the same fall in the interest rate, we've got a bigger change in output. And so the curve must be flatter. Pretty good. We did about 4 classes in one class. Let a barrel do it like this the first time. Even matter, I should say. So, you got that one? There's the intuition, there's the ground. Mathematically, we could do it, but I'm not going to. I did it in class. You can do it that way, great, go ahead. But I'm not going to ask you to. I'm not going to waste time right now.
So this is just kind of showing like the different responses.
So the question here is, tell me how the slope of the IS curve changes when investment becomes more responsive to the interest rate.
Okay.
So we're showing that the IS curve becomes flatter as the responsiveness goes up.
Okay.
Later, we're going to need this to look at policy effectiveness right after the exam. But for now, it's just looks like a mechanical thing. Then we'll put it to work.
When you ask about changing consumption.
We'll come to that in a second.
Okay.
But this is just,
Right, I understand, but I was saying that policy also makes sense.
yes,
Okay.
but only the autonomous. Well, I'll come to shifts in a second. Let's do shifts at the end.
Can you repeat what the question would be again?
The question would be, how does the slope of the IS curve change when investment becomes more or less responsive to the interest rate? And the answer is it becomes flatter. If I say explain intuitively, you give me this argument, say this is bigger, so this is bigger, so you get a bigger change, so it must be flatter. If I say show graphically, you give me this argument.
What's the label for the y-axis?
Oh, this is expenditures, Z. So what this gives you is the level of Z, the level of spending for any level of income. So it's it's a spending function. So you give this an income, it spits out a spending.
Can you repeat the question again?
The question would be, how does the slope of the IS curve change when investment becomes more responsive to the interest rate?
Becomes flatter.
It becomes flat. Here's the intuition. Okay, now I'm going to do the MPC. This is the multiplier. So how does the slope of the LM curve, IS curve, change when the MPC gets bigger or smaller? So if the MPC goes up, does the IS curve become flatter or steeper? How does the slope of the IS curve change when the MPC gets bigger? In this case, you have to know that, and we can talk about why in a second, but let me do the mechanical part first. This is a case, here's one's C of y minus t plus I of I and y. I need that over there. No, I really don't. Let's get that out of the way. Plus g. And you might have a steeper curve. C of y minus t plus I and y plus g. This is for the bigger MPC. The MPC essentially tells us how much spending goes up when income goes up. So if I start here and I increase income, with a bigger MPC, you get a bigger change in spending. The change in spending is over here. The change in income is here. So increase income, the more spending goes up, the bigger the MPC is, the steeper the curve. It's okay to memorize that and say the Z line is steeper when the MPC is bigger. I could ask you that question, explain why, but for this problem, if the question is, show me how the slope changes, you can just start with those two curves. Did you get the argument about that I was just saying? If the Z line tells us if income goes up, how much does spending go up? So this is the change in spending. And this is the change in income. Listen, got that? If the MPC is bigger, that means you get more spending when income goes up. That's what the MPC means. More goes to consumption. And so if you had more spending, Z would go up even more. And so for the same increase in income, you get a bigger increase in spending, and so the Z line would be steeper. So when the MPC goes up, the Z line becomes steeper. See that? So this is the bigger MPC. Now we just do what we did before. At I0, in both cases we're starting off at I0 and Y0. So we want to track the relationship between I and Y. So we know that at I0 we get an income level of Y0. Now we're going to drop the interest rate to I1, just like we've been doing here, and see what happens to income. So we drop the interest rate to I1, and both of these curves shift up. So the flat curve would shift like that, and we get I0 for the flat. And that's for the smaller, this is the smaller MPC. So in that case, we get that IS curve. I haven't done the yellow line yet. That's just the flatter curve. In the other case, it's going to be a little steeper, so you're going to shift like that. So you're going to get to that point. It's the same fall of the interest rate. This is C of y minus t plus I of I1 and y plus g. This is also C of y minus t. It's the same thing. Plus I of I1 y plus g. What's different is not the change in the interest rate. It's the MPC. So for the same fall of the interest rate, here's the y for the steep, or that's the bigger MPC. For the same fall of the interest rate, so this was y flat here, here's y steep here, you get an even bigger change in income. So the interest rate still falls by the same amount, but income goes up a lot more because the curve is steeper. So in this case, you get a flatter IS curve. So the bigger the MPC is, the flatter the IS curve. See that? So we just start with two expenditure functions. One with big MPC, one with a small. That gives us this point. We let the interest rate fall, it shifts both curves. We figure out where they hit the 45-degree line, and that gives us the two different curves. Now I see some heads nodding, that's encouraging. Got that?
So for the LM curve, Y is exogenous, and for the IS curve, I is exogenous?
Yes. Okay, let's do shifts next. May I erase this? You need it? Okay. All right, let's do shifts in the IS curve next. We start off this time at an equilibrium on the IS curve. So let's do C of y minus t0 plus I of I0 and y plus g0 and y0. We've already derived our IS curve, so let's just find out where we're starting on this IS curve. So we're at this point, I0 and Y0. And I want to let, all of these would be the same. G going down, T going up, autonomous consumption going up, or autonomous investment going up. Any one of those, if G goes up, this thing shifts up. If T goes down, this thing shifts up. If consumption rises, autonomous consumption rises, this thing shifts up. Autonomous investment rises, this thing shifts up. So anything that increases spending shifts the spending curve up, except the change in income. That's a movement along the expenditure function. Anything that I say on the test that makes spending go up would shift. So if I say, show how the IS curve shifts if expected future income goes up. What do you think happens to your consumption if expected future income goes up? So spending goes up, so the consumption, the spending function shifts up, because spending would go up. So anything that increases spending will shift this curve up. I'm going to do a specific example of government spending but it tended to show you exactly that. Anything at all that shifts spending up will cause this to shift up. So let's let government spending go up to G1. And we're going to hold the interest rate constant. So this is C of y minus T0 plus I of I0 and y plus G1, where G1 is bigger than G0. So we're just letting government spending go up, and we're holding the interest rate completely constant. That will then increase income to Y1 at the same interest rate. So that has to be on the IS curve, because any intersection's on the IS curve. So it has to be on the IS curve. So it must be that the IS curve shifted to the right. So the general result here is simple. Anything that increases spending shifts this curve up and shifts the IS curve to the right. The only case where that's different is a change in income, because that will move you along the IS curve. Anything that increases spending will shift the IS curve up. But if it's an increase in income, you'll actually move along the IS curve, because that's what it is. It's how I and Y are related. So that's a movement along the IS curve of income. If income goes up, your spending would go up, but that moves you along the IS curve. Anything else that increases spending will shift the IS curve in the direction that spending changes, and there's the reason. Intuitively, it's simple. You're at an equilibrium where production equals spending. Spending goes up, hold the interest rate constant, spending goes up, inventories start falling, so firms ramp up production. So at the same interest rate, you get more income. So it must have shifted to the right. Got that? Then we put all this together. We haven't used the slope part yet, but we have used the shift part. So then we put the IS and the LM curves together. We said, okay, we have this goods market equilibrium. So the goods market equilibrium that was, anyway, we're going to put the two markets together. So what we have is an IS curve and an LM curve. And where those two things intersect is the one pair, I0 and Y0, that's simultaneously in equilibrium in all markets. Now, I didn't talk at all about the forces that would push us there, but we could have talked about that. So if we were out of equilibrium, we'd get pushed back to equilibrium by some forces that we can talk about some other time. That's not part of the task. But where these things intersect is in fact an equilibrium, and it's a stable equilibrium. Out of equilibrium, we get pushed back to it. I didn't talk about that part at all. What we did talk about is graphically and intuitively what happens if G goes up, T goes, or down, T goes up or down, or M goes up or down. These two are IS, this is LM. It's convenient to index these by the things. Oh, and the other one we can do is for P, up or down. And those two are for, graphically it's pretty trivial here. If G goes up, you might want to do a different, I don't know, a different graph about it. If G goes up or T goes down, what happens in the IS curve? It shifts, we just did that, there it is. It shifts out, so it shifts out. And so, start at G0, say, there's G1 and T, well G, just like over there. And so our new equilibrium would be a higher level of income and a higher level of interest rate. And then I could ask you to explain the economics, the intuition. That's just lines on a page, that's not economics. The economics is sort of the intuition that underlies what the graph is showing you. So what's the story here? Why is it that when G goes up, Y goes up and I goes up? What's the intuition? So when government spending goes up, we can think of income going up. And so far, let's go from point A to point B. So that's what I'm talking about here. This is A to B. So that's just the goods market. So it shifts out by this amount. We haven't let the interest rate change yet. All I've done is change income. So the interest rate's still where it's at. The income goes up. What happens to money demand? It goes up. And when money demand goes up, what happens to the interest rate? It goes up. Shifts the money demand curve out, and the interest rate goes up. When the interest rate goes up, what happens to investment? It goes down, and that causes income to go down. So after we get to point B, we go back to point C. So what happens is the interest rate starts going up. That causes investment to fall, so you move along this IS curve until you get back to this higher point, point C. So this income falls from B to C. And this is what we mean by crowding out. This part here is what we call crowding out. What's happening is an increase in government spending, G, is crowding out private investment. Because there's a fixed amount of money out there to borrow. When government spending goes up, when taxes fixed, there's more borrowing. That raises the price of money. Since money's more expensive, private investment falls. So the government borrowing crowds out some of the private borrowing that's used for investment. And so you get less private investment. This will never be bigger than this. It could be as big as, the steeper the LM curve, the bigger the crowding out's going to be. But this effect is just an offset to this one. It's either partial or full. It's never more than. So this is just the crowding out there. So that's the intuition. You get to tell this story about why it is that when government spending goes up, we see the income, on net here, income still goes up, that and that. This is smaller than that, so income still goes up and the interest rate goes up. Same story for T down or autonomous spending up. Anything that drives spending up drives income up. And so all of the cases are sort of subsumed in here. So this is just, I could have just said spending goes up causes this to happen. So the intuition is the same in all those cases. So that shift, that shifts in the IS on the ISLM. We're always going to look like that. Crowding out, though, really only refers to government spending part of it. So when we say crowding out, we're really talking about when G goes up, I goes down. We get the same intuition, but we don't call it crowding out when it's taxes or something else. So the crowding out really refers specifically to that government spending case. Nevertheless, if this were taxes going down, you'd get the same thing. We just wouldn't call it crowding out anymore. Because we're really talking about when the government crowds out private investment. But if the intuition is identical in all those cases. Whew. Now let's do the other case. I can guarantee you something we talked about today will be on the test. Quite a bit of what we talked today will probably be on the test. All right, let's do it. Change in M or a change in P. So we have IS, G, and T. I could put zeros on there, but I'm just going to focus on this. LN was M0 over P0. So in this case, we have Y0, I0. Let M go up or price go down. Either one. Either one of those things. That's going to make M over P go up. And that's going to shift out the LM curve to say M, let both happen. So there's M1 over P1. You can do one or the other, same thing. I just did it. So in this case, output goes up and the interest rate goes down. So what happens to income and the interest rate if the money supply goes up, income goes up, interest rate falls? Show me graphically, explain intuitively. There's the graph. Those questions are pretty easy. Just need to figure out which direction the damn thing shifts. We just worked all that out earlier. And the intuition for this one is what? It's pretty easy. When the money supply, when M goes up or P goes down, money supply is greater than money demand. In real terms, it doesn't make any difference. What happens to the interest rate when the supply of something, what happens to the price of money? Supply goes up, it's going to fall, so the interest rate falls. When the interest rate falls, what happens to investment? Goes up. So what happens to income? Goes up. So we get a fall in interest rate and an increase in income. That's it. Pretty simple intuition for that case. There's none of this crowding out stuff. So that intuition is the same for those two cases as well. Now again, I've left some words out, but this is the story. That's a hieroglyphic summary of the story. So, must be a better word for that. It's symbolic. Symbolic representation of the words. Yes?
Did you write sentences or can you write that?
I would prefer that you do explain what's going on rather than just memorizing it. That's what I was saying earlier. A more complete answer, you'll get some credit for knowing that much. But the most complete answers would explain it all too if they have, if they could. Those are the kinds of questions I'm going to ask. What happens to income and the interest rate when autonomous consumption goes down? Explain graphically and intuitively. What happens to income and the interest rate when the price changes? Show me graphically, explain intuitively. Taxes change, government spending changes. So for the ISLM stuff, that's as much as we did. And so that's what it will be all about. Now for the algebra, you want me to do a little bit of that too? Or we finish off here, we got about 9 minutes left. Let me give you a clue about what I'm looking for there. And then I think I will have covered all the hard stuff that I expect here on the test. I didn't go over, as I said earlier, what is GDP, what is the price level, and that sort of thing, but I think that's material that you can do very easily. So, let me try to give you, I'm happy to do a homework problem if you want, but let me maybe just try to give you a more general overview of what I'm looking for. So mostly it's about finding the IS curve or finding the LM curve or finding the equilibrium. It's about finding the equilibrium always. And so what you need to start with the algebra stuff is always, what is the equilibrium in the goods market? What is the equilibrium in the money market? That's your starting point. If you want equilibrium output, you have to start with an equilibrium condition. And then you find the output that satisfies the equilibrium condition, or the interest rate that solves the equilibrium condition. To find an equilibrium, you have to start with the equilibrium condition. In the goods market equilibrium is always Y equals C plus I plus G. That's a nice chunk. For the money market equilibrium, it's always money demand equals money supply. So those are the equilibrium conditions. So all the algebra is going to start with those conditions because you're finding equilibrium values. You're finding the things that solve those equilibrium conditions. So what happens is, I give you some form for each one of these functions. You might have C equals C0 plus C1 times y minus t. These are just numbers. Think of this as being 11 and this as being 1/2. If C0 and C1 bother you, just say 11 and 1/2 when you see them. These are just numbers. They're just parameters. They just stand for some number. So don't let the letters fool you. Those are just standing for a number. If you want to think of them as a specific number, if you want to write 100 over this one and 1/2 over this one, go ahead. There's some number is all that they are. So we'll give you a consumption function. Sometimes we'll give you an investment function. B0 plus B1y minus B2i. All you do to find the equilibrium, if I say find the equilibrium output for the goods market, for a given interest rate, all you do is you plug that into there, and that into there, and solve for y. It's that easy. That's all your homework had to do. You start with the equilibrium condition, you plug in what C is, you plug in what I is, and then you solve for y. That's the equilibrium income. So if I want to find the IS curve, it's the same thing. It's just a set of equilibrium points. I plug that into there, plug that into there, and solve for y. So you say, okay, y equals C0 plus C1 times y minus t plus B0 plus B1y minus B2i plus g. Now that's just high school algebra that you all had to prove that you knew before you came here, or should have. And so now you just pull out your 8th grade algebra and solve this. And so you do it, and you get y equals 1 over 1 minus C1 minus B1 times C0 minus C1t plus B0 minus B2i plus g. So if you solve it, that's what you'll get. This thing in front is called the multiplier. This is the multiplier, and this is all the autonomous spending. That's autonomous consumption. That's what C0 is autonomous consumption. This is autonomous investment. This is exogenous taxes. Some fixed interest rate for the IS curve. And government spending. So these are all the autonomous components. This is the multiplier. But it's always the same. You just plug in what these things are and then solve for y. This is the IS curve. It's a relationship between y and I. When I goes up, y goes down. So it's a negative relationship. So this tells us how y and I are related. So this is the equilibrium income for any interest rate, government spending, taxes, and autonomous spending. This formula gives it to us. So we give it all the exogenous data, autonomous spending, autonomous investment, and so on, interest rate, government spending, taxes, hit it with the multiplier, and it gives us income back. But again, it's always the same. Y equals C plus I plus G. What is C? What is I? Plug them in, solve for Y. You do that, you're probably going to get most of the algebra questions right. So that would be the IS curve. The LM curve is even easier. Usually we say something, okay, suppose that money demand in real terms over P0 is equal to, say, D0 plus D1y minus D2i. So this is the real money demand curve. I could put P0 up front, multiply it by it. We just divide everything by P0. So that's real money demand. All you do is say, okay, the equilibrium condition is what? Money demand equals money supply. So it's going to be MD over P, and the money supply is just whatever the Fed wants it to be for a given price level. So they choose the M, there's real money. So the LM curve is just the solution to that. M over P equals D0 plus D1y minus D2i. That's the equation of the LM curve. Now I could solve for I if I wanted to. Said, well, I equals 1 over d2 times d0 plus d1y minus n1p. So that would give me an equation for the LM curve. When y goes up, I goes up. It's a positive relationship. That would be the LM curve. So I think it would be okay to say, derive the LM curve or derive the IS curve for some investment function or some consumption function, those kinds of exercises. Beyond that, what you have to do next is find, and this is what was really hard in homework, is find the y and the I and solve these simultaneously. What you do for those, and I won't ask this on the test, to find this I and this y, you would plug that I into here, and then solve for y. And that gives you this point. Then you take that y that you got, plug it back into this equation, and that's going to give you I. So you have two equations and two unknowns, and you have to solve those simultaneously. I still have 40 seconds for a question, but we timed that pretty well. So that's all the hard stuff that can be on the test. Does that help? I could ask the things that I would give you a question. So I can see equals I just that. Only the values. This is always smaller than B to C. If the LM curve were vertical, it would be just the same. So it's flat, it'd be 0, it'd be no offset. So this is always smaller than the net changes. Yes, sir. Because when the money supply goes up, money supply goes right. So this should, interest rate falls. Here's money demand. Here's money supply. At this, you start off with that interest rate. You let money supply go up. Add that interest rate. Money supply is greater than money demand. Then the interest rate falls. Here. At the initial interest rate, money supply. This line's the money demand. Move back. So money supply is greater than money demand. That means the price of money falls. So the interest rate then falls until we get to that point. Okay? Yeah? Yes. This is the money, this is money. I would give you money demand. This is the yep.
Workers, projections, like wages, it's not
Right.
like wages are too high. How say certain countries have better revenue and they can make it still. How does the amount of the worker projection affect how much the workers are producing?
So the more productive you are at a given wage, the more likely it would be that production would be in your country. Because if you have low wage and high productivity, that's going to make your goods really cheap. So the more, for a given wage, the more productive you are, the more attractive the wage. Okay. Outside the model. And so if I have supply and demand, say that demand is some function of price and income, and supply is some function of price and wages. So this, if I give, so demand depends upon income and supply depends upon wages. So if I give the model wages and income into the supply and demand model, it gives me the price and income. So for any wage, I get quantity and price. So these are the exogenous variables. Those are the things that come from the outside. And these are the things on the graph are the endogenous variables. So I give the model the exogenous variables, and it spits out the endogenous ones. If I give it a different income, say income goes up, so I feed different data in there, it gives me a different price and quantity. So price and quantity, the endogenous variables, these are the data that I give the model.
So the endogenous is in the model.
Yeah, and exogenous is from the outside. So if you take these as given, those are exogenous. Yes.
Yeah.
Yeah, outside.
Uh-huh.
X means out,
Yeah, yeah.
and N means in.
Okay.
Thursday, yes. Uh-huh.
Hey, Brett, I just want to kind of chat with you real quick about graphs. Are you going to, you have to go in the direction?
I'm gonna have to go in a minute here.
Oh, okay. And then, like I should also, Marsha said, like, when I do my reads in the book, I would, I don't know, it's kind of, I can understand the theories and stuff, and like how to do it. I'm just having a real hard time, like, connecting the theories with the graphs. I don't know, maybe it's just the way I learned it. I was just wondering, maybe I could, like, y'all should focus more on, like, graphs. The algebra I get is just, like, tying the two together, like, I don't know.
So that's probably something I should take a little more time than I have.
Yeah.
So why don't you stop by tomorrow
All right.
and come with a list of questions, exactly what you need to know,
Yeah.
and we'll go over it.
All right.
So I've been teaching for 4 hours, my voice is about gone.
Yeah.
And I got some things I need to do, and so I'm gonna go do that.